In this video, we have a beautiful combination of logarithmic series and also exponential series forming two equations to be solved simultaneously. In the first case, we have two summation r equals to 0 to infinity, that is from r equals to 0 to infinity, of log to base 2 of a raised to power r. We can simplify this to, let us put the 2, which is a constant. In the first case, we have log to base 2 of a all raised to power 0 plus log to base 2 of a all raised to power 1, and it continues indefinitely since we have a sign for infinity here. We can simplify this to 2 brackets 1 plus log to base 2 of a plus log to base 2 of a all raised to power 2, and it continues indefinitely. Now, we can find the sum to infinity of this geometric of this geometric series. This is a geometric series, and the sum to infinity of any geometric series is a over 1 minus r. A is the first term, and the first term in this case is equal to 1. Let us not forget the 2. We'll apply it as we proceed. Now, the arrow is the common ratio. The common ratio is the second term divided by the first term, or the third term divided by the second term, or the fourth divided by the third, and we can continue indefinitely like that. So the common ratio in this case is log to base 2 of a divided by 1, or log to base 2 of a all raised to power 2 divided by log to base 2 of a, which is simply log to base 2 of a. So let us put in the value of log to base 2 of a for r and 1 for a in this formula for the sum to infinity of this geometric series. So that sum to infinity will now become 1 over 1 minus log to base 2 of a. Not forgetting that there is a 2 in front of it. Now we can simplify it to 2 over 1 minus log to base 2 of a. Let's call this equation I. Now in the second case, which is this, we have summation from k is equal to 1 to infinity of 1 plus b over minus k. This is an exponential expression, and we can simplify it into the first term is 1, so 1 over 1 plus b plus 1 over 1 plus b all squared, plus we can continue to infinity. Also, we need to find the sum to infinity. It is also a over 1 minus r. The first term is this, which is 1 over 1 plus b, and the common ratio is this divided by this. It will still give us this, which is 1 minus 1 over 1 plus b. Let us now simplify this part. We have sum to infinity of 1 over 1 plus b divided by, if you find the LCM of this and 1, we'll have 1 plus b. Now, this divided by this will give us 1. 1 times 1 is 1, minus this divided by 1 will give us this. Multiply by this, we get 1 plus b. This and this will cancel out. So we have 1 over 1 plus b divided by b over 1 plus b. The sum to infinity finally becomes 1 over 1 plus b times 1 plus b over b, and this will cancel out, remaining 1 over b. This is equation II. We will now equate this and this. So we will equate equation I to II. Equation I is 2 over 1 minus log to base 2 of a. It is equal to 1 over b. Cross multiplying, 2b will now be equal to 1 minus log to base 2 of a, or log to base 2 of a equals to 1 minus 2b. Let's call this equation star because we will have to refer to it later. Let us also simplify the equation 2 as we have done for equation 1. Now, in the equation 2, the first part in the left hand side is summation k equals to 1 of 1 plus b minus k. we only need one term of this, which is 1 over 1 plus b, which is the first term. The second part is this, 1 over or 1 summation from r equals to 0 to 1 rather of log to base 2 of a raised to power 0 raised to power r rather will now be the first term, because we need just two terms of this. When r equals to 0, it is 1, and when r equals to 1, it is log to base 2 of a. We do not need to find the sum to infinity of this and this, because they are just two terms and one term respectively. So if we now put it in this form, or substituting this and this into the original equation 2, we will get 1 over 1 plus b minus, this minus here now, minus 1 plus log to base 2 of a is equal to 7 over 5. 7 over 5. So let's open the bracket. 1 over 1 plus b minus 1 minus log to base 2 of a equals to 7 over 5. Now, let us refer back to this equation, which we call asterisk. Log to base 2 of a is 1 minus 2b. We will put it here, where we'll have log to base 2 of a. So 1 over 1 plus b minus 1 minus 1 minus 2b, which is our log to base 2 of a, is equal to 7 over 5. If we open the bracket, 1 plus b minus 2 plus 2b is equal to 7 over 5. Now, let us collect like terms. If we collect like terms, 1 over 1 plus b plus 2b equals to 7 over 5 plus 2. The LCM here is 5. This is 7 plus, and this is 10. That is 17. So 1 over 1 plus b plus 2b equals to 17 over 5. We now need to clear this fraction. So I will multiply through by 1 plus b and also by 5. Let me first of all multiply through by 1 plus b. So here it becomes 1, because if I multiply this by 1 plus b will cancel 1 plus b, remaining 1, plus 2b brackets 1 plus b equals to 17 over 5 times 1 plus b. Now, if I also multiply through by 5, I'll have 5 plus 10b, 1 plus b is equal to 17, 1 plus b. Let us now open the brackets. So 5 plus 10b plus 10b squared is equal to 17 plus 17b. Good. So collect like terms. So I will have equation 10b squared. This will cross minus 17b plus 10b. This will also cross minus 17 plus 5 is equal to 0. So 10b squared minus 7b minus 12 equals to 0. We now have a quadratic equation. Let me do a little commercial. Please like this video if you find it interesting. Subscribe to my channel if you haven't done so, and also share this video. Sharing is an act of love, and love doesn't cost a thing. Now back to business. So we have a quadratic equation in B. Let us solve it using sum and product. The sum is minus 7b and the product is minus 120b squared. We'll now have to look for two numbers that are factors of minus 120, such that when they are added or subtracted, we'll have minus 7b. Those numbers are 15 and 8, because 15 times 8 is 120. So I have 10b squared minus 15b plus 8b. Minus 15 plus 8 will give me minus 7. Minus 12 is equal to 0. I will now group the equation. In the first bracket, 5b is common. If we bring it out, will remain 2b minus 3. In the second bracket, 4 is common. Bring it out, we'll have 2b minus 3, because 4 times 3 is 12, and this times this is this, equals to 0. These two brackets are the same. We'll take one and put these other ones into a bracket, 5b plus 4, and then equate each bracket to 0. When that happens, b is equal to 3 over 2 or b is equal to minus 4 over 5. Now let's put in each values of b so that we can find the value of a using this. We can simplify it into 2, 1 minus 2b as power is equal to a. Good. So let us find the value of a respectively for the value of b. So in the first case, when b is 3 over 2, 1 minus 2 times 3 over 2 will give us a. And then 2, 1 minus, if we divide this, we'll have 3 equals to a. So 1 minus 3 is minus 2. So 2 minus 2 is a. And therefore, a equals to 1 over 4. Also, when b is equal to minus 4 over 5, 2 bracket 1 minus 2b, which we have here, is equal to a. And then b is minus 4 over 5. So 2, 1 minus 1 minus, let us put a 2 here first, minus 4 over 5 is equal to a. So minus times minus is plus. 2, 1 plus 8 over 5 is equal to 8. The LCM of 5 and 1 is 5. 5 divided by 5 is 1. 1 times 8 is 8. 5 divided by 1 is 5. 5 times 1 is 5. So we have 5 plus 8 is 13. So 2 raised to the power 13 over 5 is equal to a. So to finally summarize, we are asked to find a comma b, and we have two solutions. A comma b is equal to, in the first case, when a is 1 over 4, b is 3 over 2. And when a is this, that is 2 raised to the power 13 over 5, 2 13 over 5, what is our b? B is minus 4 over 5.